Algebra 1, 6.6, solve absolute value inequalities. So, for example 1, solve the inequality, graph your solution. The absolute value of x is less than or equal to 9. The distance between x and 0 is less than or equal to 9. So, x has to be somewhere in between negative 9 and 9. So negative 9 is less than or equal to x is less than or equal to 9. The solutions are all real numbers greater than or equal to negative 9 and less than or equal to 9. So they're both or equal to, so we're going to put closed circles on negative 9 and positive 9. And it's in between those, so we're going to shade in between. Okay. Now the absolute value of x is greater than 1/4. So the distance between x and 0 is greater than 1/4. So either x is greater than 1/4 or x is less than negative 1/4, because it has to be farther away than 1/4. So the solutions are all real numbers greater than 1/4 or less than negative 1/4. So here's 1/4. Here's negative 1/4, and here's positive 1/4, and we are shading out because they're farther away from 0 than those two numbers. So the inequality, the absolute value of ax plus b is less than c, where c is greater than 0, is equivalent to the compound inequality. Negative c is less than ax plus b is less than c. And the inequality, the absolute value of ax plus b is greater than c, where c is greater than 0, is equivalent to the compound inequality. Ax plus b is less than negative c, or ax plus b is greater than c. Okay, so if the distance is less than a number, then it's a compound because it's closer to 0 than that. And if it's greater than, that means it's farther away from 0 than that, so we have to shade out. Okay, so solve the absolute value of 2x minus 7 is less than 9. So our distance is less than 9. So we can write it as a compound inequality. So it's going to be negative 9 and 9. So that's our number out here. So we can add 7 to each expression to get this out of the way. So then we add 7 here, we get negative 2, 2x, and add 7 here, we get 16. Then we divide each expression by 2 to get x by itself. So we get negative 1 is less than x is less than 8. So our solutions are all real numbers greater than negative 1 and less than 8. Okay, so negative 1 is here and 8 is here. We don't have or equal to on either, so we draw open circles, and it's a sandwich inequality, so we shade in between. Example 3. The absolute value of x plus 8 minus 4 is greater than or equal to 2. So our distance is greater than whatever number we get when we add 4 over. So first thing we have to do is add 4 to both sides, and we get 6. So the distance here has to be greater than or equal to 6. So we have to write it as two separate inequalities. So it's either greater than or equal to 6 or less than or equal to -6. We made this negative, so we had to flip our sign. Okay, now we subtract 8 from each side. We get -2 and -14. So our solutions are all real numbers greater than or equal to -2 or less than or equal to -14. So it's greater than or equal to, so we put a closed circle. We shade greater than that. We put a closed circle on -14 and shade less than that. So we had to use an or, so we shade out, not in between. Okay, now you have a checkpoint. Go ahead and pause the video and do those. For solving inequalities, step by step, follow the steps for solving an equation, but reverse the inequality symbol when multiplying or dividing by a negative number. For compound inequalities, if necessary, write the inequality as two separate inequalities. Then solve each inequality separately. Include and or in the solution. If it's and, you shade inside, and if it's or, you shade outside. Okay? Absolute value inequalities, if necessary, isolate the absolute value expression on one side. Rewrite the absolute value inequality as a compound inequality. And then solve the compound inequality.